There are certain things that you do for multiplying and dividing terms that are different for when you add or subtract terms. So in order to understand this, we're going to first break the term into two different parts. We've got the number part right here, and we've got the variable part. In the number part, it involves the sign, whether it's negative or positive, and I'm going to put a negative sign here because a negative means that it is to the left of 0, and a negative sign is not invisible, unlike a positive sign that is invisible until it becomes an addition sign. So in this part here, we're going to have a negative and then a 3. So this is where the number part would go. Negative, you've got the sign and the number part. When you're looking at the variable part, we would have any letter, and so let's just go with R for right now. R, and then it also has an exponent, and the exponents are these numbers that go up here. They're small, they're to the power of, so let's go ahead and go with the power of 2. So the number part has a sign and a 3. So if it was a positive 3, then we wouldn't even see this right here. It would just be 3. But if it's negative, the negative goes here to the number part. And then we've got the variable and the exponent, okay? So let's look at what we need to look at if we're adding or subtracting. If we are adding or subtracting, there are certain rules we have to do. Both terms have to be like terms, okay? In order to know whether something is a like term or not, we look at the variable. The variable has to be the same letter and the same exponent, okay? So, for example, if we are going to add 2x plus 5x, okay? These are like terms because the variable x to the first power and x to the first power are both the same. They have the same letter and they have the same exponent. Now, if you're confused, wait, how is this to the first power? Because remember, any time you don't see an exponent, that means there's an invisible 1 here, okay? And that's important, especially when we are looking at multiplication and division, so of terms. So here, the variable's the same, and the variable's the same. So when we're adding, we can add these two terms together because they're like terms. If one of these was, let's say this was an R, then we wouldn't be able to add it. We just couldn't do anything with it. But because they're the exact same variable, we can. And so when I'm adding 2x and I'm adding 5x, since my variable is going to stay the same when I'm adding, I just go ahead and put an x in my answer, okay? Because the variable is going to stay the same for all of it. It's x to the first power is going to be in my answer. Then I just add the number parts. Here the number part's 2. Here the number part's 5. 2 plus 5 is 7. So my answer is 7x. Another way to look at this is if I've got 2 x's and I add 5 more x's, how many x's do I have? I've got 7x, okay? Now, so again, the key thing you need to remember is if you're adding or subtracting, they have to be like terms. They have to have the same variable. That goes for if you don't even have a variable. Let's say you've just got 3 plus 7. You can add these together because they don't have variables, so they are like terms. Let's say you had 3m plus 7. Could we add these together? No, we could not, because this doesn't have an m in it, and so they're not like terms. Now, let's look at multiplying, okay? When we're multiplying or dividing, we don't have to have like terms, okay? If we have like terms, we can still multiply. If we don't, it doesn't matter. We can still multiply. So let's look at some examples here. Let's pretend like we have 3x multiplied by 5x to the third power, okay? So what we here we've got the number part and the variable part. The number part and the variable part. So, first thing, let's multiply the numbers. 3 times 5 is, if you don't know, use your calculator, but it's 15, okay? So the number parts are just done the same way we do normal multiplication. We multiply the numbers together and we're good. Now, notice we do not have like terms. This is x to the what power? To the first power, because we've got that invisible 1 there. X to the first power times by x to the third power. The way you do it in multiplication is you look at it and make sure they're the same letter. This is an x and this is an x. And so because they're the same letters, we're going to add their exponents. I'm going to write that down. We add the exponents. And that's right. When we divide, we subtract the exponents, but we'll look at that later. So here we're going to add these, okay? Here we've got x to the first power, and if it helps you to write an invisible 1 up here, just so you remember, do that, okay? So here we've got 1 plus 3. It's 1 plus 3 is going to give me to the fourth power, and then my variable, the letter is x. So my answer is 15x to the fourth power. The letter stays the same, but I add the exponents, and that's my answer there. 15x to the fourth power. Okay, now let's look at division. So if we've got a 5a to the fourth power divided by 6a, what we're going to do here, let's go ahead and write it in, okay? We're going to take the number part here is the positive 5, and now the variable part is a to the fourth power. Here we've got the number part is the positive 6, and then the variable is a to the first power. And again, that 1 is invisible, but if it helps you to write it there, write it there. Now what do we do? Okay, we actually divide the numbers just normally, okay? Sorry, this isn't going to be a clean number here, but we've got 5 divided by 6, and I'm actually just going to leave that in fraction form. 5 divided by 6, okay? So I did the number parts, 5 divided by 6, and I'm just going to write that as 5/6, okay? And I could do the decimal if you want to do that. You could write the decimal there. But this part is just normal division. Now we need to divide the variables. We've got a to the fourth power and a to the first power. Remember, when we multiply, we add the exponents. In division, we subtract them. But first, we got to make sure it's the same letter. This is an A, this is an A, so we can add their exponents. So we've got subtract their exponents. We've got 4 minus 1, because again, this has an invisible 1 there. 4 minus 1 is 3, so this is going to be an A to the third power. So my answer would be 5/6 A to the third power, okay? Let's look at a few different ones here, okay? Let's pretend like we've got 15W to the sixth power divided by 3W squared. Can you do that? Okay. So first thing we do, we look at the number parts. We've got a 15. We divide it by 3. So 15 divided by 3 is going to be 5. Now we look at the variables. Here, they are the same letter, W and W. So because this is division, we're going to subtract the exponents. So 6 minus 2 equals, and if you don't know, use your calculator, it equals 4. So my answer is going to be, I'm going to put the variable part here, W to the fourth power. So my answer is 5 w to the fourth power. Let's look at a different one, okay? Let's pretend like we've got 6r times by 5, okay? So here, what we have is a multiplication problem. This one has a variable, this one does not. But because this is multiplication, we don't care about like terms. So we're going to multiply them anyway. What we're going to do here is multiply the number parts first. 6 times by 5 is 30. Now here we've got an r, but there's no variable here, and this is an r to the first power. So there's no exponents to add to because all we have is this one r to the first power. So we're just going to write it as r to the first power, okay? One last example, okay? Let's pretend like we've got 2x multiplied, or let's actually 2x to the second power multiplied by 3y to the third power. Now, when we multiply this, we look at it, we've got the number part and the variable part. Number part and the variable part. These are not like terms, but it doesn't matter because this is multiplication. It would matter if it was addition and subtraction, but we're not adding or subtracting, we're multiplying, okay? So what are we going to do? First, we multiply the number parts. 2 times 3 is 6, okay? Now, we've got an x to the second power. Are there any x's over here with exponents that we can add it to? No, there are not. We only have this one x to the second power, so we're actually going to put that in our answer as x to the second power. Now we look at this variable, y to the third power. Are there any y's over here where we can add the exponents to? No, there are not. So then this y to the third power goes in our answer as well. So we have 6x to the second power, y to the third power, and that is our answer, okay? Now, I see people sometimes combine these variables because they see two different variables when they're adding or subtracting. You cannot do that with adding and subtracting. The only time you can do this is if you're multiplying or dividing.